Welcome to Lesson 10.3, Volumes of Prisms and Cylinders. So, couple things now that we're done with surface area, just to clarify, when we move into volume, now we are looking at the space that a 3D figure or solid occupies. So we want to think about the overall three-dimensional space that a prism, such as this one here, or a cylinder would occupy. So volume of any prism or cylinder happens to be the exact same equation, which is volume is the product of its height h and area capital B of its base. So bringing back the capital B from our surface area formulas, volume equals capital B H. Or again, easy way to think about it, volume equals the area of the base figure multiplied by the height of the prism or cylinder. So volume is measured always in cubic units. So meters to the third power, meters cubed or cubic meters, inches cubed, feet cubed or cubic feet, etc. So when we think about area, surface area, always to the second power because it's dealing with two-dimensional spaces. Volume is dealing with three-dimensional space, so always to the third power. So let's look at our first example, our rectangular prism. The height of the prism, because it's laid sideways, we need to identify the height, which is that length of 14.5 meters. Our base are the two congruent rectangles here and here, which is 3 by 5. So the area of the base, 3 times 5, 15 square meters. Height of the prism, 14.5. So our volume, multiply the two, and our overall volume is 217.5 cubic meters. Example 2, looking at a cylinder. Right away, I identify on the cylinder, the diameter is 12 feet. So because I'm using an area formula, I want the radius, cut the diameter in half. Radius of that base would be 6 feet, and we know the height of the cylinder is 9 feet. So the area of the base, which is a circle, is pi r squared. So using the exact area, that would be 6 squared, which is 36 multiplied by pi. So we could write it as 36 pi. Or if you're using an approximate area, 113.1 square feet. So then our volume, area of the base, 36 pi square feet, multiplied by the height of the cylinder, 9 feet, giving us 324 pi cubic feet, or our approximate volume, 1017.9 cubic feet. Moving on to example 3, a triangular prism. So our area of a base, which is a triangle, is 1/2 base times height. And remember, anytime we're talking base and height, we're dealing with them being perpendicular, meaning they have to meet at 90 degrees. So when I'm thinking about the base of this triangle, it'd be 5.5, the height would be 6. This 8 over here is a slant height of a side, not the base or height of the triangle. So the area of our base triangle, 1/2 multiplied by 5.5 multiplied by 6, which is 16.5 square meters. Height of the prism, the 12 meters, right here, height of our prism. So then 16.5 multiplied by 12 gives us an overall volume of 198 cubic meters. Moving on to example 4, dealing with a hexagonal prism. Now I don't expect you to necessarily draw this whole prism, but you do want to keep in mind the base figure being this regular hexagon. And that's a key, knowing that we're dealing with a regular base, because that tells us all the side measurements are the same, and allows us to use the area formula for any regular polygon, 1/2 multiplied by the length of the apothem multiplied by the perimeter of the base. So in this case, we have our hexagonal prism that's 5 yards tall. So height of the prism, 5 yards. The base, each edge is 5 yards, and it was that regular hexagon. So we have a hexagon, each side being 5 yards. And then we have the apothem, which is 4.3 yards. So our perimeter of our base, 6 times 5 is 30, which you can tell I messed up the first time I wrote these. Apologies there. But 30 multiplied by 1/2, so 15, multiplied by 4.3 gives us an area of 64.5 square yards. So then we want to take that 64.5 multiplied by 5 to give us an overall volume for this hexagonal prism of 322.5 cubic yards. Example 5. We're going to have to work our formula backward because they give us the volume of a prism at 420 cubic centimeters. Now, what I'm going to do for the sake of my problem, because you can see I wrote that as 430, I'm just going to make you change this in your notes, little teacher approach, to 430. So we're going to say that this prism is 430, not 420. And the height of the prism is 30 centimeters. Find the area of the base. So if volume is the area of the base times the height, volume divided by height will give us the area of the base. So we would take our volume, which I changed to 430, divided by our 30 for the height, giving us an area of the base of 14 1/3, 14.3 repeating if you did that in your calculator, which is 14 1/3 centimeters squared. And then moving down to the final example here, example 6. And I'm going to get rid of this. All right, so again, we're back to a volume scenario with a cylinder. Tells us the volume of the cylinder is 80 pi. The diameter is 8 units. Find the height. So if we think about a cylinder here with a diameter of 8 units, I know then the radius would be 4 units. And I also know if I want to get the height, I need to do volume divided by the area of the base, and that'll give me the height. So first need to find that area of the base shape. So we know it's a circle. Area is pi r squared. Radius is 4, so 4 squared being 16. So the area of our base is 16 pi. So we take our 80 pi for the volume, divided by our 16 pi, telling us the height of the cylinder is 5 units. And then one last note here. All the figures that were in these examples were right figures, where the area where the base meets the height at a perpendicular or meets at 90 degrees. So the symbol here, perpendicular. If we had a slanted cylinder or a slanted prism where it's known as an oblique figure, you would look for the perpendicular height to the base, which should be given to you in most diagrams. So just be careful of that if you're dealing with anything that is oblique or slanted. Still ends up having the same volume if it was right or oblique. Lastly, knowing that you're in honors geometry, these examples are not exactly the same as the ones in the lesson in your book. And there are a couple questions in the practice problems about a principle that is covered in the book lesson. So after going through this video, I do ask that you take the time to go back into your book lesson for 10.3, at least read about the principle and through a few of the examples to help you with the practice problems.